4 of the most powerful telescopes on the planet, and off it, just looked at the same object and came back with the same unsettling answer. We got it wrong. For almost a year, the world believed 3I Atlas was simply another frozen wanderer passing through, a comet like any other, just from somewhere else. But new data pulled together from Hubble, the James Webb Space Telescope, the Very Large Telescope in Chile, and NASA's SphereX mission has quietly rewritten what we thought we knew. And if you haven't been following this story closely, what's coming in the next few minutes might genuinely shock you. Let's rewind to where it all started, because the beginning of this story matters more than most people realize. On July 1st, 2025, the ATLAS survey, that's the Asteroid Terrestrial Impact Last Alert System, picked up a faint, fast-moving speck of light from its station in Rio Hurtado, Chile. The telescope first reported observations of what would become Comet 3AC Atlas to the Minor Planet Center that day. At first glance, it looked unremarkable. Just another object drifting through the outer solar system, the kind astronomers catalog by the thousands every year. Science daily. But the math told a different story. When researchers ran the orbit, they found something that made their stomachs drop a little. This thing wasn't orbiting the sun, it was just passing through on a one-way hyperbolic trajectory that would eventually sling it back, out into deep space forever. That single detail changed everything. It meant this object didn't form here. It came from another star system entirely, flung out by some ancient gravitational event. And after who knows how many millions or billions of years drifting, through the emptiness between stars, it happened to cross paths with our solar system. That makes it only the 3rd interstellar object ever confirmed, after 1I Oumuamua in 2017 and 2I Borisov in 2019. Hence the name 3I Atlas. And almost immediately, astronomers went back through the archives. Using older sky survey images, they found pre-covery shots of the object dating back even earlier than the official discovery date. Some analyses traced it as far back as mid-June 2025, quietly sitting in the data before anyone noticed. Which raises an uncomfortable question we'll come back to later. How many of these things have we simply missed? Here's what made 3I Atlas different from day one. Oumuamua was small, dry, tumbling, and left scientists arguing for years about whether it even had a tail. Borisov behaved more like a normal comet, but was faint and hard to study in detail. 3I Atlas, though, bigger, brighter, weirder, and moving fast, clocked at roughly 137,000 miles per hour at discovery, a speed that only increased as the sun's gravity pulled it inward toward perihelion. Within days, observatories across the globe pivoted their instruments toward it. Everyone understood the clock was ticking. Interstellar objects don't stick around. They pass through once, and then they're gone, back into the dark, never to return. So astronomers effectively declared an all-hands emergency, coordinating observation windows across Hawaii, Chile, South Africa, and multiple space telescopes, determined not to waste a single night of data before the object slipped out of range. What they found in those early weeks was strange enough to raise eyebrows. But what they've confirmed since then, through the back half of 2025 and deep into 2026, is the part almost nobody is talking about yet. Because here's the twist. 3I Atlas made its closest approach to the sun, its perihelion, on October 29th, 2025. And a lot of researchers genuinely expected it might not survive that. Encounter intact. Comets are fragile. The heat and radiation near the sun can crack them apart, the way we watched happen to other sun-grazing comets in the past. It didn't disintegrate. It came out the other side of that perihelion pass in one piece, and that alone forced a huge rethink. Because if this object, potentially billions of years old, older than our own solar system by some estimates, could survive a close solar flyby without shattering, that tells us something about how tough, how structurally different material from other star systems can be compared to the comets we're used to studying at home. And that's really the heart of what this video is about. Not just, here's a comet from another star. It's what 4 of Earth and space's most sophisticated instruments found when they looked closer. Chemistry that doesn't match anything in our solar system's playbook, a size estimate that kept changing every time someone remeasured it, and a composition pointing to an origin so old it predates our own. Sun. Webb found something in its coma that broke the standard comet formula entirely. Hubble captured images that didn't match textbook cometary behavior. The Very Large Telescope detected an element you basically never see in a comet's spectrum. And SphereX delivered a size estimate that left researchers stunned before later measurements forced yet another correction. Before we get into exactly what each of those 4 telescopes found, and just how recently some of this data has been confirmed and refined, right up through the first half of 2026, I want you to sit with this question for a second. If a scientific team spends a year with the best instruments on and off this planet, and they still can't agree on how big this thing actually is, what does that tell you about how much we still don't understand about what's passing through our solar system right now? Stick with me, because in the next section we're getting into the James Webb data and the number that made astronomers do a double take. All right, let's pick up exactly where we left off. The James Webb Space Telescope and the number that made astronomers do a double take. When Webb turned its infrared instruments toward 3I Atlas back in August 2025, researchers were expecting something fairly routine. Comets, as a rule, are water machines. When sunlight hits an icy nucleus, water ice sublimates, turns straight from solid to gas, and that's what powers the glowing coma and the long tail you see stretching across the sky in photos. Every comet we've ever studied in detail, including Borisov, follows that basic script. Water leads, everything else follows. 3I to Atlas didn't follow the script. Webb's early measurements found a coma that was overwhelmingly dominated by carbon dioxide, rather than water, with a CO2 to water ratio far higher than anything seen in a solar system comet at a comparable distance from the sun. That's not a minor quirk, that's a comet behaving like it came from a completely different chemical environment, maybe a colder region of its home system, maybe a spot where water ice had already been stripped away long before this object ever left its star. Either way, the implication is enormous. It suggests that not every planetary system builds its comets out of the same basic ingredients ours did. Some of the fundamental rules we've built comet science around for decades might just be local rules specific to our own solar neighborhood. Then, a few months later, Webb delivered a second surprise. In December 2025, well after the comet had already rounded the sun, follow-up observations picked up a robust detection of methane in the coma, CH4, a molecule that's genuinely rare to confirm this, clearly in a comet's spectrum. Combined with the earlier carbon dioxide numbers, you start to get a picture of an object built from a very different volatile inventory than what we typically see close to home. Methane, remember, is exactly the kind of molecule astrobiologists get excited about, not because it's a sign of life on its own, but because it's one of the simple carbon-based building blocks that shows up in discussions of prebiotic chemistry. Now, let's talk about the Very Large Telescope in Chile, because this is where things get genuinely eerie. Using spectroscopy, essentially reading the chemical fingerprint hidden in the faint light bouncing off the comet's coma, researchers detected cyanide, which, while unusual to say out loud, actually isn't unheard of in comets. It's a fairly well-known cometary molecule tied to organic chemistry. What stopped people in their tracks was something else entirely: metallic nickel and iron showing up in the gas coming off this object at distances from the sun where you'd almost never expect metals to be sublimating into gas form at all. Multiple follow-up studies through the winter of 2025 into early 2026, tracking that nickel and iron signal with instruments on the VLT, confirmed it wasn't a fluke or a data glitch. The signal was real, and it persisted for months as the comet moved away from the sun. Researchers have since connected this metal signature to something called the metal-carbon monoxide correlation seen in other comets, suggesting the metals are likely being released as part of larger, more complex molecules, something like metal carbonyls, rather than pure raw metal boiling off the surface. Interesting on its own. But the bigger headline is simpler. An object carrying that. Much processed metal mixed into ice this old is consistent with material that formed in, or was shaped by, an environment far more chemically violent and metal enriched than the quiet dust cloud that built our own solar system. And here's where the age question comes back in, because it's not just speculation dressed up as drama. Based on its interstellar velocity and trajectory, it entered our solar system moving at roughly 58 kilometers per second relative to the sun on top of solar gravity. Astronomers calculated a kinematic age estimate that puts 3I Atlas somewhere between 3 and 11 billion years old. Let that sink in for a second. Our own solar system is about 4.6 billion years old, so depending on where in that range the true number falls, this object could be older than the sun itself. A genuine relic drifting through space since before Earth existed, carrying a chemical record of a star system that may not even be around anymore. Researchers have also noted something else worth mentioning here. This object is statistically unlikely to have passed this close to any star before, meaning our sun's gravity may be giving this ancient wanderer its first real close encounter in billions of years of drifting alone in the dark. So here's where we are after Webb and the VLT. A comet with backwards chemistry, no reliable water dominance, robust methane, and metals that shouldn't be sublimating this far from the sun, wrapped around a nucleus that might predate our entire solar system. That's already a lot to process. But we haven't even gotten to the part where scientists couldn't agree on how big the thing actually is, and how the two most trusted instruments in the business, Hubble and SphereX, ended up telling two very different stories about its size, before more recent data forced a correction that's still being debated in early to mid-2026. That's coming up next, including the moment scientists thought they were looking at an object nearly 10 times bigger than expected, and what changed when they looked again. Let's talk about size, because this is where the story gets almost comedic if it weren't so scientifically significant. 4 world-class instruments, and for months, none of them could agree on how big this thing actually was. Start with Hubble. On July 21st, 2025, Hubble's Wide Field Camera 3 locked onto 3I Atlas and captured what became one of the defining early images of this object. A teardrop-shaped cocoon of dust streaming off a solid, icy nucleus, with background stars streaked into lines because Hubble was tracking the comet's motion across the sky. Based on that imagery and follow-up observations through August 20th, 2025, astronomers put out a size estimate with an almost frustratingly wide range. The nucleus could be as small as roughly 440 meters across, or as large as 5.6 kilometers. That's not a small margin of error. That's the difference between a modest city block and an object that could swallow most small towns. Why such a wide range? Because from Earth, you can't easily separate the tiny, solid nucleus from the much larger, brighter cloud of gas and dust surrounding it, the coma. Depending on how much of that light is nucleus versus fuzzy halo, your size estimate swings wildly. It's a bit like trying to measure a light bulb's actual size just by looking at the glow around it from across a room. Then came SphereX, NASA's newer infrared mission, which took its own measurements in the following weeks. Early size estimates coming. Out of that data pushed the number even higher, with some assessments suggesting a nucleus that could stretch past 40 kilometers across if the object were unusually dark and absorbing more sunlight than expected. For a moment, that number had researchers stunned. A body. That size would make 3IR Atlas not just bigger than Borisov, but potentially the largest cometary nucleus ever measured in modern astronomy, interstellar or otherwise. Naturally, that figure spread fast. It's the kind of number that grabs headlines. But science doesn't stop at the first exciting number. It keeps checking. And this is the part of the story that often gets left out of the more sensational coverage. As 3I Atlas moved past perihelion and out into the colder, calmer part of its journey, Hubble got another crack at it. This time using a technique specifically designed to strip away the glow of the coma and isolate the light coming only from the solid nucleus itself. That refined analysis, published in a peer-reviewed paper in March 2026, landed on a much more modest and far more confident number, an effective nucleus radius of about 1.3 kilometers, give or take roughly 200 meters, putting the diameter in the range of 2.5 to 3 kilometers. Other independent estimates using the comet's non-gravitational acceleration, essentially how much the outgassing itself was subtly steering its trajectory, landed in a similar ballpark. So where does that leave us? Nowhere near the 40-kilometer monster some early estimates suggested, but still meaningfully larger than Oumuamua or Borisov, and still one of the most massive interstellar nuclei confirmed to date, with a mass estimated in the tens of billions of kilograms. The lesson here isn't that scientists got it wrong, it's that this is what real science looks like in real time. Messy, self-correcting, occasionally dramatic, and always willing to update the number when better data comes in. If anything, the size confusion is proof of just how hard it was to pin this object down, even with the best instruments humanity has ever built. Pointed straight at it. Now, about that Mars flyby we teased earlier. On October 3rd, 2025, 3I Atlas swept past Mars at a distance of roughly 18.6 million miles, close enough that spacecraft already orbiting the red planet, including ESA's Mars Express and Trace Gas Orbiter, got a genuine front-row seat. These missions weren't designed to chase comets, but engineers repurposed their cameras and spectrometers on the fly, capturing an independent set of observations that helped cross-check what Webb, Hubble, and the VLT were finding from much farther away. It was, by most accounts, one of the more improvised and impressive bits of astronomical teamwork in recent memory. Then, on October 29th, the comet swept behind the sun at perihelion and briefly vanished into solar glare, becoming unobservable for a stretch of weeks. When it reemerged in late October and into November, astrometric tracking resumed, and, as we covered earlier, it hadn't broken apart. It kept going, fainter now, but intact, continuing its outbound journey. By March 2026, the comet was reported to be passing near Jupiter's orbit on its way back out of the solar system, still faintly visible to major telescopes, still being tracked, still surprising people. And this brings us to something almost nobody expected to still be talking about in the summer of 2026, the SETI Institute. Using the Allen Telescope Array at the Hat Creek Radio Observatory, researchers scanned 3I Atlas across a wide range of radio frequencies in June of this year, specifically checking for any technosignature. Any hint of an artificial signal that might suggest this object wasn't purely natural. The result, reported just weeks ago, nothing. No artificial signals detected, further reinforcing what the chemistry, the imaging, and the behavior had already strongly suggested. This is a natural object, not a probe, not a ship, not anything engineered. Just an extraordinarily old, extraordinarily strange piece of another solar system, drifting through ours. But natural doesn't mean boring. Far from it. Because once you put together everything these 4 telescopes found, the backwards chemistry, the surviving nucleus, the shifting size estimates, and now the confirmed absence of any artificial signal, you're left with an object that's arguably more scientifically valuable than if it had turned out to be artificial. It's a real physical sample of material from a star system that may not even exist anymore, delivered to our doorstep with no return trip planned. And in the next section, we're going to talk about what that actually means for how we think about our own solar system, why so many researchers now believe this is only the beginning of a much bigger pattern, and what's coming next as 3I Atlas fades permanently out of view. So let's step back and ask the question that actually matters here. What does all of this add up to? For decades, comets were treated almost like leftovers, frozen debris left over from the formation of our own solar system. Interesting mostly because they're time capsules of our local neighborhood 4.6 billion years ago. Interstellar objects change that entire framing. They're not leftovers from our system, they're messengers from someone else's. And 3I Atlas, more than Oumuamua or Borisov before it, has turned out to be an unusually detailed messenger. One we happen to catch at exactly the right moment, with exactly the right instruments pointed in its direction. Think about what's actually been confirmed here, pulling all 4 telescopes together. Webb showed us a coma chemistry dominated by carbon dioxide instead of water, plus a confirmed methane signature that doesn't match the standard cometary formula we've built our models around. The VLT detected nickel and iron persisting in the gas for months, tied to a metal-carbon monoxide correlation that suggests this object may have formed in, or been shaped by, a far more metal-enriched environment than our own solar nebula. Hubble tracked the nucleus through a full perihelion passage, watched it survive intact, and eventually nailed down a much more precise size. After early estimates swung wildly in both directions. And SphereX, despite that initial eye-popping size estimate that later got revised down, still played a critical role in helping researchers cross-check activity levels and refine just how much material this thing was shedding as it approached the sun. Individually, each of those findings is interesting. Together, they form something closer to a complete profile. Chemistry, structure, age, and behavior, all pointing toward the same conclusion. 3I Atlas was very likely built in a different kind of stellar nursery than the one that made Earth, possibly one dominated by heavier elements, possibly one where water ice never had the chance to become the default building block the way it did here. And based on kinematic age estimates putting this object somewhere between 3 and 11 billion years old, there's a real chance the star system that built this comet burned out and died long before our own sun ever ignited. That's not a small claim. That's the kind of finding that quietly reshapes how researchers think about planet formation across the galaxy. Not as one universal process that plays out the same way everywhere, but as something that can look wildly different depending on where and when a star system happens to form. If 3I Atlas is representative of anything larger, it's a hint that our solar system's particular recipe, water-rich, carbon-modest, relatively metal-poor comets, might be just one version among countless others scattered across the Milky Way. And then there's the detection problem, which honestly might be the most unsettling part of this whole story. Remember, pre-cover images later showed 3I Atlas had already been sitting in survey data for weeks before anyone noticed it. An object multiple kilometers across, moving on a hyperbolic trajectory through our solar system, went unflagged until routine sky survey software happened to catch it. If a comet-sized visitor from another star can slip past our detection systems for that long, the honest question becomes, how many others have we simply never caught at all? Oumuamua and Borisov were both discovered somewhat by luck, using instruments not originally designed to hunt for interstellar objects specifically. With upcoming more sensitive sky surveys coming online in the next few years, many researchers now expect interstellar objects to go from once-a-decade curiosities to something detected far more regularly, which means 3I Atlas may not be a once-in-a-lifetime event. It may just be the first one we were properly equipped to study in this kind of depth. As for where 3I Atlas is now, as of the most recent tracking data through mid-2026, the comet has continued its outbound journey, passing near Jupiter's orbit earlier this year and steadily fading as it moves farther from the sun. Researchers expect it to remain faintly observable to the largest ground and space-based telescopes for at least another year or two, with projections suggesting Hubble and Webb could still catch glimpses of it as far out as 2027, before it becomes too distant and too faint to track at all. After that, it disappears, permanently, back into interstellar space, carrying whatever secrets it hasn't already given up, headed toward a destination and a timeline that stretches so far into the future it's almost meaningless to us as individuals. And that, honestly, is the part of this story that sticks with people. We had a window of maybe a year and a half to study an object that spent billions of years drifting alone through the dark before crossing paths with us, and we'll likely never see this specific comet again. 4 of the best telescopes humanity has ever built spent that window doing everything they could, and they still walked away with more questions than answers about where exactly this thing came from, how old it truly is, and how many more of its kind are out there waiting to be found. So here's the question I'll leave you with. If an object this large, this old, and this chemically strange could go undetected for weeks before anyone noticed it, what else might already be out there, quietly crossing into our solar system right now, waiting for the next survey update to finally flag it? If this breakdown helped you make sense of what's actually been confirmed about 3I Atlas, separating the real peer-reviewed findings from the speculation, do me a favor and hit that like button, subscribe if you're new here, and drop a comment with what you think. We'll find the next time an interstellar visitor passes through. Because based on everything researchers are saying right now, the next one might not be nearly as far off as we think.